Hello, hello. We
Hey,
are live on the internet. All right, yeah, I think we can hear and see each other, so we should be ready to roll. So, good morning, good afternoon, good evening, people, wherever you're tuning in from. Thank you for being here. It is another Thursday, so it's another time for a Pragmatic AI and .NET show. I'm your host, Sam Basu, developer advocate at Una Platform. And with me today, I have my good friend, Daren May. How are you, sir?
I'm very well. How are you doing?
I am doing good. So it's around 11 a.m. Eastern time for me, but you are 2 hours behind or ahead of me. So yeah, it's early morning for you.
It is, it is. Just got up, had my coffee, ready to go.
Yeah, there we go. There we go. All right. So let's get situated here. I think we are streaming to all of the places. Our chat room warms up slowly, but for folks who are watching this live, do let us know where you're tuning in from. We love to know. Let's see. LinkedIn users, hi folks. Hello, hello. So yeah, we love to know which part of the world you're tuning in from. Time zone differences are amazing to see sometimes. It's the magic of tech. Darren, you are in Mountain time zone. I'm in Eastern, but we are together live on stream today.
Exactly. At least it's
Okay.
daylight for both of us.
Yeah, exactly. Yeah. All right. So this is a show for folks who might be watching this for the first time where we like to know what people are building in reality with AI. And it's the age of AI. It's transforming how we build software. There's a lot of hype to get around, lots of things flying around each day. But what's real? Like, what are some developer workflows that we are actually using to ship software? So, Darren, why don't you maybe introduce yourself, please?
Sure. As you say, my name's Daren May. I'm based in Colorado. I work for a company called Kahua that basically produces a asset management construction software that has a very substantial market footprint and is very innovative. And part of the reason why we were able to innovate so much in recent times is because of our adoption of AI. The development team, the organization as a whole is all in on AI.
Yeah, well said. And I still see, I don't know if you do, Darren, where, I see the purists who are like, no, I'm writing all of the code by hand, which is, hard stance to take these days. But let me ask you this: like, I see, and I have differed a little bit in this stance for the last, few months. AI generates, like, with all the guardrails, it generates a ton of code very, very quickly. But it's a whole different, conversation to say, is that code actually working? Is the feature actually functional and what you want built? Which is why, our stance has been like everything should be human code reviewed before it goes out to production. But even that's getting harder and harder each day. So what's your stance on that?
So, I think there's a few different aspects that you're really talking about there. One is as a personal practitioner, as a developer, as perhaps a codes craftsman, what is happening? And, I'm not alone in this, but I speak about this very much in terms of it's the industrial revolution for code.
Yeah, exactly.
That, if you look back at the industrial revolution, you used to have machinists that would create your nuts and bolts, and they would create them at very high precision, but it was a very low volume output. Along comes the industrial revolution, along comes automation, along comes these production lines, and all of a sudden you've got machines that are producing 500 bolts as opposed to one bolt every 10 minutes, and so on and so forth. And so obviously that craftsman's position now becomes somewhat rarefied in that, yes, there might be somebody who has a very bespoke need for a particular bolt that the machine can't produce, and then you still need somebody with those skills to be able to produce it. But in the main, the economies of scale rather mean that it's much more cost effective to go and get those that are sourced from the machine. And so the position of that craftsman starts to reduce. There's less need for that craftsman. And to a certain extent, they've either got to retool, learn new skills, perhaps to support the machines that are producing the bolts, or they're going to have to find something else to do. And I see a very similar thing within, the developer landscape. Now, as you say, there are definitely purists out there that they love code. They love writing code. They love that feeling of producing code. And I do count myself amongst that. I've been coding for a very long time, and I do love getting hands-on with code. But also, we're developers that are employed by companies. And although we tend to think, we're employed to code, no, we're employed to solve problems. We're
Exactly.
employed to build revenue for the companies of which we work. And so if there's a more efficient and effective way to do so, then it's incumbent upon us to adapt to that and to adopt the tools and patterns and practices that best exploit it. Now, of course, you mentioned the other thing, which is, okay, let's say the impact on me using AI is now I'm producing 2, 5, 10 times as much code. And sometimes it's producing more code than I perhaps would have produced myself, because I don't have to be as efficient with my resources. If I'm writing code, it takes me twice as long to write 2,000 lines of code as it does to take 1,000 lines of code. Using AI, I don't have to be that efficient. I can actually write very verbose unit tests. I can write huge amounts of documentation and comments and put them into my code. So I'm not so focused on the time it takes me to produce it. But as you say, then you've got the review side of things, which is, and we all tend to pick up on catchphrases like vibe coding. I'm not a fan of vibe coding, the term. AI slop. I'm not a fan of AI slop, but that term is used generally, but it's kind of the garbage in, garbage out. If you don't constrain it, if you don't specify what it is that you want it to build, and perhaps how you want it to build it, and what success criteria means, it's going to build something that isn't in line with what you're expecting, right? But if you haven't set those expectations, you've allowed the gap to exist. You mentioned, human code reviews. Human code reviews remain essential. Doesn't mean we can't use AI to assist in those reviews. And we do that. Within Kahua, we've got a number of tools that we leverage to help us take the 5,000 lines of change that have been created in a PR and perform initial checks on it. Look for security flaws, look for coding practices that are bad, make sure that there are tests created, make sure the tests have decent test coverage. A whole bunch of checkboxes before I even look at the code myself. And so that helps with efficiency and so on in terms of managing these large volume of reviews. There are still some areas, obviously, where AI can wander off. And some of that's more to do with context pollution than it is with AI's inability to get stuff right. We manage a lot of that by producing a lot of architectural documents, a lot of memories, a lot of guidelines, and so on, that can be pulled in by the agents as they're working, so that they follow pre-existing patterns of implementation rather than dreaming things up. One area, actually, we do find that there's still a lot of challenge is taking, say, Figma designs, high fidelity, pixel perfect Figma designs, and having the AI understand that, oh, that's actually an existing component. So I need to use that existing component rather than turn around and say, oh, I need to build a new component and going away and doing it. That's one area where we do have additional guardrails in place. But yeah, in general, we still need humans to verify that the architecture is sane, that it aligns with our existing code base and isn't dreaming up some new thing that's going to sit out there and have to be maintained.
Yeah. Well said. And to your point, I think code is a means to an end, and that end is solving a problem. I also see nice phrases being thrown around that code is, yes, cheap. AI is not cheap, but code generation is cheap, but software is not. That's where you need the human to orchestrate everything. Right. So our role is essentially evolving. And you mentioned Kahua a few times, so let me drop that in the chat here, because you folks do amazing stuff. So hold on, I'm trying to get your webpage up. There we go. So I'll drop this in here. So if anyone's interested in what Daren and the team are building in here. We have also had Colin on the show. You
Yeah.
folks do amazing things. That's Kahua. Oh, and our good friend Sasha is here. Hello, Sasha. Yeah.
Hey, Sasha.
So, you mentioned Colorado. So, I've seen Daren a few times in person, but you're based in Denver, Colorado, and you folks put up a very nice show where I got to hang out with you in person again. This is Denver Dev Day, if anyone's in the area. So do drop by. This
Yeah.
is Denver Dev Day. So it's a one-day great conference. Happens in a community college where we get together to share knowledge.
Yeah,
So
it's a community event that we do, and Kahua is a sponsor of that event, and so is Uno platform. So we're very grateful for that support, and we obviously love it when people from Uno, such as yourself, come out and present and so on. It's great.
yeah, absolutely. So we've talked through some of the basics. How about I share your screen? You walk me through your setup, because that's a thing that I'm always interested in, because we are all, using AI in slightly different ways. We have our workflows. We have our ways of figuring out what works and what doesn't for us. Hawkman, friend of the show. Good morning. Good to see you from Austin, Texas. So Daren, if you're ready, I'm going to bring up your desktop.
Sure.
All right. So tell me your dev setup, like your workflow of how you get things done, your choice of tools, and so on.
Sure. I mean, there's really two eras I would talk about. There's pre us going all in on AI and after AI. I started using Visual Studio, or into dev as it was way back in the past.
That's a term I haven't heard in a while.
Yeah, back in 2000.
Yeah.
I was on the beta of .NET, and so I've been using Visual Studio as my primary interface for writing code for 25 years. And obviously use Visual Studio Code as well for more of this kind of scripting, but always really relished the sort of integration that you get in an IDE such as Visual Studio. But over time, Visual Studio has got heavier and heavier and heavier. And it has its own solution infrastructure that becomes more and more complex and unwieldy to handle, especially in very large enterprise projects. And so I started drifting towards using Visual Studio Code as my primary coding interface, with various plugins, extensions, and so on that augmented that. But when we started to really go all in with AI, it became ever more apparent to me that the amount of time I spent actually directly editing source code was becoming much less. We all went through that sort of continuum of evolution. It started off with AI is, it's your equivalent of Bing or Google. You put in search terms, you get answers, you copy it, you drop it into your code, and away you go. And it's still your code, right? Because that's how most of us was coding anyway, cut and paste divas, right? But then you started, as the tooling sort of improved and it had the ability to reach in and comprehend your source and so on, what we started to notice was the plugins for Visual Studio versus the plugins for Visual Studio Code. There was an ever-increasing gap in the capability. There's more overhead running in Visual Studio versus code and so on, and became much more efficient to run purely in code. Once we started getting to the point where you can embed your files or source ranges, it can really search your local repos and so on and so forth. This window on the right-hand side started taking up more and more room of my editing experience, rather than, actually maximizing my code space, because most of my work was going on over here, right?
Yeah.
And so, yes, very much so, we're using Visual Studio Code as our primary development environment. I mentioned we're using, sorry.
Yeah, I was just going to say, like, I'm in the exact same boat, because I think a lot of us are, because like we have traditionally used Visual Studio for .NET, and again, like I know the team that puts together Visual Studio very well. It's just a big ship to steer, and some of the AI models and the tweaks and with the agents and the little services and the MCPs, the cadence of release is very, very fast. So
Mhm.
it's just a difficult thing to keep up. And to your point, and Visual Studio is a fantastic IDE. It's heavy-handed because it brings everything together, and maybe in your everyday you're not needing all of it.
Right.
Um, yeah. So you are using AI and Claude Code in here inside of Visual Studio to kind of guide AI to do things for you.
Mhm.
But you are saying like the middle section where you actually look at code, unless you have a need to go look into a file, you're mostly looking at the AI window, right?
That's correct. Yeah. It's just the adapted workflow. Now, we kind of mentioned Visual Studio there for a second. The one place where I still find it to be the tool of choice is when I have to do a lot of debugging.
That's
Is the
true.
debugging experience in Visual Studio is still hands down the best
Mhm.
experience that you can get.
Yeah.
You know,
Yeah.
and obviously
I
you can
agree with
still
that.
plug your AI into it, but Visual Studio is still much better for debugging.
Yeah, yeah. I mean, the code authoring, system with Roslyn, like it's more or less the same. But you're right. Like some of the debugging and the team testing solutions, those are still probably best done in Visual
Yeah,
Studio.
performance monitor and those sorts of
Yeah,
things.
yeah, yeah,
That's it's very useful inside that framework.
yeah. Now, let me ask you this, like before you show me more things about your setup, like I see folks who are, so AI adoption is a spectrum, right? We are all over the place. Some of us are a little bit hesitant, some of us are cautiously trying to adopt, while the others are very forward. And the forward-looking folks have switched to using either command line or apps like, Cloud Desktop or GitHub Copilot app, where you are not even looking at a code editor, like you are driving your AI and only pulling up code when you need to inspect something.
Mhm.
So, do you see yourself in that mode ever?
I I'm certainly not against that mode. I mean, one of the primary reasons why I still remain primarily in Visual Studio Code is I produce a lot of Markdown documentation as part of
Hmm.
my workflow, and so it's very easy and simple and straightforward for me to be able to open those up and preview those Markdown documents to review what's going on. By default, Claude will produce, its plans and so on in sort of temporary workspaces that you can view and so on. But I prefer to have them explicitly in locations that are either part of my repository, or I actually have a general shared repository that I use for my general work in Kahua. So I've got a whole library of folders based around any bug fixes, features, whatever I'm working on. So I've got a single repository that maintains a history of all that documentation.
Hmm.
And I've always been very documentation centric. I've always felt that it's incumbent upon the developer to record what they're doing so that it can be shared for posterity. It makes it easier to hand over if somebody else needs to maintain your code. And in this new agentic world, the agents still gain a benefit from reading architectural documents rather than having to reinvent the wheel each time. If anything can stop your context bloating, it's not reinventing the wheel every time you do a prompt or so on and so forth. So I like to have this evolution of documentation that kind of talks about where I started, what the plan was, how that plan is progressing. And I like to have my sort of primary agent and any sub agents updating that documentation as they go. Because the other thing is, every now and again we get a black screen of death and we lose what we're doing. And if we don't have these artifacts, it becomes difficult to
Hmm.
recover.
Yeah. Yeah, I've also seen people talk about this where, your context window, you mentioned that, like as we are talking to our agent, it's keeping track of a lot of things and it's not, it cannot go on forever, right? So at some point after like several hours, you might see the agent do a compaction, in which case it's trying to summarize the conversations that you have had. And while that's okay for the agent to keep going, you just lose a bunch of context. So I've seen people try to avoid getting to a point, or at least write it out in their docs, like that summarizes some of the things that you're doing, with the agent.
Well, absolutely. And you talk about sort of your context bloating and long-term conversations, because that tends to be what happens. We all start off with a good prompt initially, or hopefully we all start with a good prompt, and then we go, no, that's wrong. Do this, do that, do that, and we end up with this whole dialogue as if we're dealing with an intelligent entity rather than actually providing concise instructions. And over time, that pollutes your context.
Yeah.
And the things that your agent and the LLM are drawing from that as the key principles that should be driving its responses start to get blurred and lost over time. And there has to be a point where you turn around and cut your losses and start a new session. And to a certain extent, I view the compaction as an aspect of starting a new session. But the difference is AI is choosing what's important when it compacts rather than you. And so I tend to like to get it to generate a summary of what it thinks is where we're at and what it's prioritizing, and then review that and correct and inject things that are, oh, no, you're emphasizing the wrong thing. There's actually a great example within the repository I'm going to talk about here in a little bit. And that is that, so we produced this thing as a series of demos to showcase some capability. And we'll touch on this a little bit more.
Yeah, absolutely.
In the doing of that, I didn't have it create any tests. It was just get this done because we're going to be in build tomorrow and we're going to need to show this stuff. When I asked it to produce a document, and you can actually see it listed there, authoring a new game prompt, it reviewed the code base and assumed, because there were no tests there, that there was an explicit requirement not to create any tests. So it documented in that guide, do not create any tests, which is absolutely opposite to what I would suggest and what I would recommend. And it decided, because there were no tests, that must have been a concrete, explicit do not. And so that's a classic example of AI looking at things and coming up with a completely incorrect assumption around it.
Assumptions without guardrails. Yeah, so I would love to actually dive into this, but let me talk to the chat room here for just a second. Our good friend Alvin is here. Hey, Alvin, good to see you. Same time zone. And yes, Alvin and actually me are going to be seeing each other soon. Let me point this out. For those of you who are across the pond in Europe, we are headed to .NET Day in Switzerland next week. So it'll be good to see you there, Alvin. So Alvin does agree. VS Code is getting very, very good. In the world that, Daren and me and Alvin live in, cross-platform C#, it's actually getting very, very good because of all of the tooling and because of some of the hooks that we have to, bring up simulators. So I think Alvin is talking about Jonathan Dake, who runs the Maui team over at Microsoft, and how they're using GitHub Copilot to fire up, simulators. Yeah. So I think the tooling and the adaptability of the tool chain and the pipeline is, really, really good in Visual Studio Code. And again, like I know the VS Code team as well, they are churning as quickly as they can. It's very competitive, right? So for everyone to, try to keep you on the code editor, they have to churn out features that really combine the agentic work with the need to see and orchestrate your code base quite a bit. Right. So before Daren, maybe I see the name of this demo, and I think I know where you're going with this. So Microsoft Build happened, I think early June, right?
Yeah.
So we were sponsors, and yeah, exactly. So we and Kahua and Uno Platform, we showed up together as sponsors at Microsoft Build, and we had a booth where we were showing off demos across platform C# and Uno Platform all day. And then Daren is like, hey, let me do something fun because why not, right? So you came up with some amazing demos that are games, really polished UI using Uno Platform and SkiaSharp. So walk me through what this solution is, and it looks like you're using Cloud Code all in on this. So, walk me through.
Sure. So to kind of set the scene, why are we talking about Uno Platform? Why are we talking about SkiaSharp? So Kahua uses the Uno Platform to deliver our product across multiple surfaces. We've got the Windows desktop, we've got WebAssembly running in the browser, we've got iOS and Android apps. So we've been using the Uno Platform for a very long time. And you guys re-architected your product to move away from rendering using the native stack to using SkiaSharp to render your pixel perfect UI across all of these platforms. And we embraced this very early because the first version that we moved to was Android, and the increase in performance was off the scale. The brokering between the .NET runtime going through the Java native interface into the Java stack, into the native controls and the whole life cycle there was just a huge amount of overhead that was really slowing everything down. As soon as you guys switched over to your SkiaSharp rendering, I would say performance improved tenfold within the application. It went from being usable but not pleasant to being a wonderful experience. And then of course that rolled out through the entire stack, and at the end of last year, we moved from the HTML DOM based version of the product over to the Skia rendering product in WASM, WebAssembly, WASM. And, again, the performance gains there are enormous. So, we've been all in with the platform, and we've inherited SkiaSharp as part of that capability. But we also had a lot of experience using SkiaSharp directly. I built a PDF rendering capability with a custom markup engine inside the Kahua product. And we were using SkiaSharp to render the PDF itself, as well as all the markup and everything like that. So we've been using it before it even became the sort of primary presentation layer. We've modified that now to take advantage of what you guys are doing with Skia. You've got an SK canvas element that effectively exposes up the underlying shared canvas element that Uno is using. So we don't have additional device resources in use. We can go directly to the metal, as it were. So that's kind of how we came to be sort of using this and working with you guys. And then, of course, you guys have embarked upon a journey where you're now co-maintainers of SkiaSharp, and that's enabled SkiaSharp to start absorbing in the latest versions of Skia. Skia being Google's sort of accelerated 2D rendering platform that Chrome and so on and so forth are built up on top of. And so when we were going to kind of put together this idea of a showcase, we thought, okay, well, let's bring in SkiaSharp 4, the preview versions of SkiaSharp 4, and really try and exploit the performance gains that gives us, like 2.5 years of evolution on the Skia platform, and really see, okay, what can this do? And of course, as we'll see, it really enabled remarkable experiences, not only just in terms of games and so on and so forth, but also some interesting demos in terms of very graphically intense renderings that run very well. So,
yeah. So this is, by the way, the SkiaSharp 4 thing that Daren's talking about. Since June, it has actually gone GA. And this is Microsoft, I think Alvin mentioned Jonathan Dick's team. This is Matt Leibovitz and us collaborating together. So we are all in this together, right? We are maintaining this together because we see the power of, a truly powerful cross-platform rendering, that, same consistent UI everywhere. And to me, like when I'm using SkiaSharp, like I'm mostly thinking about apps, but you kind of took it to a different direction with games.
right.
And that's amazing to see, because games are very intensive in terms of their performance needs.
Absolutely. And it's a very different sort of conceptual thing. You've got two types of rendering, really. You've got retained mode and you've got immediate mode. Retained mode is typically how apps work, that you've rendered something and it is retained until it is refreshed. And then you've got something like a game, which is redrawing its UI 60 frames a second, 120 frames per second, whatever frame rate you choose, or whatever frame rate you can achieve. And so that's a very different paradigm and so on. So I was interested to see, okay, can I adopt that within the context of a C# Uno app that's leveraging SkiaSharp? And obviously the answer is yes. So this is kind of the home screen that we put together for our sort of demos. And just a note, Kahua we leverage a lot of Hawaiian terminology within our applications and so on. So all of these homages, we sort of came up with a Hawaiian translation. So asteroids is pohaku, which is stone in Hawaiian, and so on and so forth. So that's kind of the model there.
You know, can you remind me? I forget. Like, what does Kahua mean in Hawaiian?
It means foundation or fortress.
Foundation.
So it's
there you go.
The Kahua platform is the foundation for these construction software solutions and so on.
Yeah. So these are, and by the way, the UI looks amazing from the, just from the start, and Daren hasn't even gone into a game, but these are like the iconic, terminal arcade games that we grew up with. So it has that immediate draw, and you are able to run all of this with C#, with SkiaSharp on desktop. Does it also run on the web?
Yes, these all run perfectly fine in WebAssembly as well. I did not build mobile versions just because I didn't want to deal with creating on-screen input controls and all those sorts of things. But it will actually run on mobile. You just, it doesn't matter if you tap the screen, there's no input controls there.
Yeah.
So, the idea here, we've got a landing page and thought, okay, what if Bob Ross was really bad at drawing? So that was the idea here. It's a happy little Hawaiian homage to classic arcade games. But when I originally wrote it, I actually wrote it using this neon theme. So if I just hit T, it just toggles the rendering engine for all of these items and brings up the neon theme. So we'll go back to our happy little Hawaiian homage. So I'm going to launch Asteroids. So the genesis of this was actually within Kahua, we have these sort of developer days where, everybody down tools for a day and we just play around with new technology. That's how we were able to accelerate our adoption of AI initially, when a lot of us hadn't actually used much of it, was to turn around and say, okay, we're going to take a day, we're going to install these tools and go and try and build something in a day that you would never have been able to build on your own, just hand coding. And I actually was tied up with a bunch of other things, but I felt like I was missing out. So at the end of the day, I thought, okay, what's something I could knock out quickly? And so I just asked Claude to write a version of Asteroids. And so let me launch that.
I'm getting the sounds. There we go.
So here was, and believe it or not, it produced the initial version of this Asteroids within about 10 minutes.
Wow.
So let me start it up so it actually... And so...
You're using a keyboard and mouse to navigate?
I'm using my keyboard here, using arrow keys, or I can use the WASD,
right,
and then space fires. And so all of this is, just using the SkiaSharp 2D rendering primitives, drawing multiple frames per second and so on and so forth. Yes. Got the full implementation, and I died. And so, it just blew me away.
I was going to ask, is the source code for any of these out there?
Yes, so I did share them. I don't actually know whether we flipped the switch yet to move it public, because I shared it with you guys to help you iterate on the SkiaSharp release. I do have a GitHub repository. So maybe
I'm asking about the source code for the games.
Yes, that's exactly what I'm talking about. So I do have them on a GitHub repository. I don't know as I've flipped the switch to make it fully public yet. So we'll probably look at doing that.
Yeah.
What I was going to show you on here once it comes back. But when I did the initial rendering of this, it's like, oh, that's a bit boring. So I added this vibe, which toggles it over to neon. Let's turn that off so it's not so noisy. But the idea then was, well, it was so easy to create that. Can I create a reusable game engine that will shorten the life cycle of building much more complicated games and so on and so forth? And so that was the idea there. And so Hokulele, which is Hawaiian for shooting stars, is a homage to Galaga.
Galaga, yeah, the classic. I gotta tell you, folks, like if you are ever at a booth and if you want people to just not walk by, just pull up one of these games. Like for especially, 80s, 90s, 2000 kids, like it's difficult for us to see this running and just walk away.
And so again, this was an evolution of the engine to enable something like this. And one of the things that I said to Claude when it was writing this was, I want this to work unattended. So I want you to have an attract mode that will play the game so that we can just leave it up there and we don't have to have somebody engaging with this. If you pay attention in here, you'll actually see that the Kahua and the Uno logos are actually present as the bosses.
Oh yeah, I see that. That's cute. I had not noticed that. That's amazing. Yeah,
they exist within there.
Yeah.
So anyway, those two games were the foundation of kind of the engine, and from there it's like, okay, let's just go ahead and build a whole bunch more. So you've got your Pac-Mans. This launcher, by the way, compiles if the local version hasn't been cached, and so it just compiled and launched. So this is a version of our favorite Pac-Man. That's a tortoise, I should say, and lizards instead of ghosts, and so on and so forth. Again, keeping the Hawaiian theme and so on. So yeah, a lot of fun putting these things together.
I got questions here because this is mind blowing, Daren. And by the way, like when you had these things running, especially in the unattended mode, it is so attractive for people want to play because this is what we grew up with. So a couple of questions. One is like as you started making more and more of these games, are all of the games using a shared physics library?
They are using a common code area. So this is architected a little bit differently than you might normally build one of these apps. And the reason for that is because we were having to use different versions of the preview versions of SkiaSharp. So each of these projects had different versions. There was a time when some of the filter effects were crashing on certain
not
versions,
there, yeah,
and so on and so forth. So rather than having a single DLL with everything, I actually just had a common code area that just get linked in to each of those areas. So that's where a lot of the engine exists, is in the common area.
Yeah.
So inside common here, we've got a chassis. So this is where a lot of the shared code exists for that. Audio. So audio, when I first built it, there was no audio because there was no built-in platform audio.
Because I was going to ask, like, how did you find these? Like, they look like original game audio, right?
Actually, no. They're what I did was I fed into Claude. I want a sound effect that sounds like X.
Oh, I see.
And it would then develop the profile of the sound, and it uses a NuGet called NAudio that is available cross-platform. Uses JavaScript in the browser to produce the audio, or goes through to native audio generation on Windows and so on and so forth to encapsulate all of those things.
Yeah, it's just amazing what AI tools with the right guardrails can do.
Absolutely. And so sorry,
I was going to say, like, especially things like things that were way beyond our purview as developers, like like I'm used to writing code, but if you say go and stitch this video together, I'm like, I don't have the tools.
Right
now it's just ask for what you want with the right guardrails and it does all of it.
Yeah, and I mentioned before how I like to produce documentation to capture everything and so on. So I have this whole architecture folder in here where it kind of summarizes what the repo is, and you might notice that this is a detailed diagram here that you wouldn't necessarily expect to see within Markdown. There's this graphics library called Mermaid.js.
Oh yeah, yeah.
Used to produce flow diagrams, activity diagrams, and so on. So I instruct my AI to produce these diagrams using Mermaid.js. And Visual Studio Code's preview for Markdown was recently enhanced with the ability to render inline Mermaid.js. It used to be you had to have an extension, but you may recall there was a security issue where a bunch of extensions could actually backdoor. And so a lot of these things got incorporated into the core Visual Studio Code product. And one of them was the ability to be able to preview these diagrams in there. But, you know, it's just its own type of Markdown. So the nice thing about this is AI can read this and understand this as well, because it's text rather than having to try and interpret a PNG or whatever of the image. And so, you know, this kind of gives an overview of all the elements, how they relate together, the structure of the project. Then basically, you know, you can drill in and you can see class diagrams, interactive diagrams, and so on.
Oh, look at that.
That talk about all of the flow and how to build all of these things. You know, we spoke about audio, so we can look at how the audio works and how it works with the desktop versus the WebAssembly having to play through JavaScript. And so you can see all of these things. And, you know, I have this stuff built as it goes so that if we encounter the need for a new effect or something in a game, we can revise this document to add that capability in, and then it's there for the next run to work out how we're going to build the next game or add the new features and inherit the ones that already exist. So then I basically turn around and say, okay, create a document that tells me how I would create a prompt to build a new game. And so, you know, this gives you guidelines on all of the key things that you need to incorporate in your initial prompt to produce your a new game. These are the things, for example, you would tell your new session that this is the required reading to go and understand the architecture and the constraints in which you're going to build the solution. So this, you would include this in your prompt. Then block 2, this is where you identify what your game is going to be, whether, you know, homage, give it its title, and so on and so forth. This is your elevator pitch, a summary of what your game is going to be. You might reference existing games to turn around and say, you know, if the game's got a square playfield, then it's going to be based upon Aloha. If it's got a fixed portrait field, then base it on these. So as I've added new games into this flow, we've extended the paradigm. You know, you start off with asteroids, which has kind of got a wraparound play area as opposed to an encapsulated play area. So if you're going to create something that's bounded, then you've got a new set of rules. So you add it into the rules engine so it understands it. New class of game enabled. You've got, for example, there's a Defender. You remember Defender, the horizontal scrolling?
Yeah.
So you've kind of got much wider than your available space play area. You've got a radar at the top. So those are new game engine features that got added in and so on and so forth. And so this calls that out.
This is very detailed because, like, everything that you would need to extend this or build a new game, you have it documented. So you're not leaving anything to chance for any AI agent to get into new game dev. So let me ask you a question here. So, like, I see overview, I see shared assets, I see rendering, audio, build and deploy. So you have every step of this documented, and this is a part of your repo.
Yes.
So that any agent can read this. But is this to a point where, like, if I come into this repo and if I say build me a new game, and if I do not give it anything, like, I'm asking whether, like, it's actually going to step through like a planning mode, like a spec doc, where it actually builds this out, because without it, it's not going to try to even come up with a new game.
So that's what I did yesterday. Was I said, okay, let's create a new game. It probably took me 10 minutes of my attention for it to produce it.
There you go. Yeah.
And
so it's asking you those things up front.
Yeah. So basically, I took the prompt that's specified in here. So let me come back to that. So at the bottom here is an example prompt. Here it is. So here's an example prompt. So I copied that and I created my own version. So this has all of the things like the game state, what I want to have in here, how it's going to kind of interact and so on.
Yeah. So given all of this, like you're essentially wanting AI to fall into a pit of success. Like, don't guess.
Exactly.
This is exactly what I want. Yeah. So
So,
like,
sorry.
yeah, I was going to ask, like, so how do you feel about agentic skills? Because like you're kind of doing it by hand here anyway. So like this could
Yes,
be wrapped up into like a skill or that I can maybe install. Then I have the
absolutely.
same, yeah, things.
That's kind of the sort of the continuum of the evolution, right? Is you start off with documents and then you refine those documents and you distill them down to the point where you can express them as a cogent skill. Because the challenge sometimes is if you make your skill something that boils the ocean, then it doesn't do
Right.
the particular thing you want well. And so I tend to go through an iterative approach to that. I start off with a simple prompt that says, this is what I want it to do. I tell it to look at this template and to fill out this template. And because, it kind of understands this game concept, it can fill out a lot of this information for me. I review it and tweak it to make sure that it understands it's going down the path that I want it to go down and to include certain things. And then I run it. And then that, as you say, in plan mode, okay, now create a plan. So this is the plan that prompt produced.
Mm.
So now you can see, it's got the elevator pitch, but it's really started to expand things out now because it's looking at the architectural documents. So it's now starting concretely to determine what it's going to create, where it's going to pull those things from, any additional game specific elements that need to be created to support the game. It understands that, this is dig dug. So it's a whole bunch of layers of earth that you're going to dig through and you're trying to kill enemies within there and so on and so forth.
Oh,
So,
really? I have not played that for some
well, you'll see it
reason.
in a second.
Okay.
I'll have to send it to you. And it just goes down and follows on. Some of the things you don't necessarily think of is, all of these games have a camera.
Mm-hmm.
Those cameras are generally locked to the player, so the player stays in the middle. But when the player moves to the edge of the play area, instead of constantly scrolling the play area across, the camera then stays frozen and the player moves around the camera. So that, you need to have those concepts baked into the engine so that it can deal with these things. Harpoon, what happens when you stab things? How do boulders behave? So if you dig underneath a boulder, the boulder is going to fall. If you're in the way, you're going to get squashed. If an enemy's in the way, then the enemy gets squashed and so on and so forth. So just behaviors, but you can see how it's expanding out from all of my ideas, concrete implementation of how this stuff's going to work. It understands the sound effects that are necessary. So it defines a short filtered noise scrape, rising square blip, short click. So it starts to generate the code that's actually going to produce those elements, and so on and so forth. Then
Yeah, this is so detailed. I love it.
yeah,
And agents will soak up all of this structure because they like to break up their work into smaller buckets and then just
right.
do one thing at a time.
Yeah, and you mentioned agents. I tend to like on any sort of non-trivial activity to have my main sort of session agent is really working as an orchestrator and delegating specific activities off to sub-agents.
Oh, so you are using sub-agents.
Yeah. Those sub-agents may be, writing code, or one of my particular favorites is having a sub-agent that is running as an antagonistic code reviewer.
Yeah.
We all know these antagonistic code reviewers in person, the guy who is going to pick the holes in everything, but your code is better for it.
Yeah.
And so having something independent and being adversarial in terms of, okay, look for a reason not to accept this code. You tend to get a different perspective on it. Yes, some of the stuff might be trivial and pedantic and you dismiss it, but some things might actually be, hey, you're doing a lot of allocations here, which you don't need to do. Why don't you do this instead? And in an enterprise application, allocating memory and tying them up in objects and waiting for garbage collection, that's an incredible sin that you really want to avoid as much as you possibly can. So those sorts of things are very key. The other advantage of using sub-agents is they're running in their own context. They have their own allocation. They only get a small subset of your current context, and they return back results that may be only a few lines instead of something that adds significantly to your main context, so it can help avoid context bloat.
Yeah. So you're saving your main context, and I also like this where not everything needs an opus or a fable. Like there are slower tasks, like so delegate to the cheaper models because you don't need them.
Right, and especially now that the costs are going up, you've got to make that pragmatic decision around, is this just a real simple task? I'm going to use Haiku. Is this something that's going to need a little bit more intelligent interactive? Okay, I'm going to use Sonnet. But if I'm planning something like this, as an example, I'm going to use Opus. If I've got a real gnarly architectural bug in my large enterprise app, I might use Opus with max thinking because I need it to really think about all of the blast radius impacts of change and so on and so forth. But then once I've got a plan, once I've got all that detail, I don't need something that's going to keep rethinking that plan, which is what Opus has a tendency to do. Delete this file. Let me think about this file. Where is this file? Are there other files that are like, I don't need that. Just delete the file, please. Right? And so again, it's, as you say, it's choosing the right tool for the job.
Yeah. Very well said. All right, so you have everything pretty much scripted out. You have a plan, and then you are going to feed all of this in, and it starts creating. How do you test stuff? Like once code's been generated, how do you know it's working?
So there's some really interesting capabilities with these agents. So, as I mentioned before, initially there were no tests in this project, but I actually did get it to write full tests. But that doesn't mean it was untested. What it was actually doing was it was using a PowerShell script to do screen grabs. And then it was actually analyzing the screen grabs to make sure that elements were positioned correctly, things were moving around, that the attract mode launched, that it went through. So, and it did that of its own volition. It's not something that I told it to go ahead and do. Uno has MCPs that allow you to obviously interact with things and so on and so forth. This built its own. And I didn't even notice it was building its own until I actually got it to start documenting when I wanted to add testing. So
let me plug this in here for a second, since you mentioned MCPs, and MCPs are actually wonderful. So this is, for those of you who do web-based UI testing, you might be more familiar with like Playwright, but that's only for web apps. What this is really is for all types of native .NET apps across desktop, across mobile, and so on. So it'll actually go in and start testing out your UI, so you have more confidence in what agents are building. And this is for the future, but we are thinking of expanding this thing because there can be so many ways. Like you talked about enterprise apps. What about your performance benchmarking? What about, you have a set of UI tests that you have written up. Now you just want a runner to go and execute them. So, MCPs can be very handy for, all of those. All right, so I see PowerShell scripts. What are they doing?
So as part of all of this, I have it generate all the build scripts necessary to build each individual one or to build all of them together to be able to launch them. The actual launcher here is leveraging these scripts behind the scenes, kicking off processes to launch all of those things. So, that's just it compiling Eli in a release configuration.
Nice. I mean, this is again like I talk to people who think that .NET is for serious enterprise devs only, but here is .NET running games. Here is .NET running desktop and web. So that's the power of the foundational platform that you're on.
Right. So here's Eli or Dig Dug. So this guy
Oh,
goes
this
running
is
around.
fun.
As it has to dig, it slows down. So you've got different types of critters and so on are after you.
Oh, nice.
Play it.
Oh, I need
You've
that.
got particle effects on here. Let's wait for that guy to come along. So there's an example of a rock. So if I go underneath that rock, that falls and
I see.
everybody and so on and so forth. So yeah, that's Dig Dug. So again, a completely different type of game. Built, as I say, 10 minutes of effort from me, leveraging a lot of that kind of neon engine. And the way all this neon effects work is it draws everything twice. One with a very large blur on the element to simulate kind of this blur or this glow. And then it draws it again with high fidelity over the top. So you get the sharp. So this is how you kind of get the blur effect on all the boundaries here and all that sort of stuff.
Actually, this reminds me. I was going to ask you something because you mentioned this up front. Like SkiaSharp, it's drawing once, which is what you need for apps. But here you are drawing it multiple times a second based on your frame rate. So how does it know to diff between frames so it's not drawing the whole thing over and over?
So in this particular game, because the volume of so you've got a couple of different things going on. Because it's a fairly simple surface that's being rendered here, it will run through the process of drawing, but it honors clip. So it understands the clip of the viewport and will discard anything that's outside of the viewport. The way that this is running is there's a tick. So it's rendering a frame every 1/20th of a second or whatever, depending upon whatever frame rate we've chosen. And so it's going to completely redraw the canvas in that sort of timeline. And that's because, you have all manner of different pulsing effects. If we've got the attract, let me launch that up again.
And it's performant enough for you to,
oh yeah,
yeah.
I mean, you might see some lag on this just because we're running presentation software right now. And this screen is being harvested to be shared. But
yeah, and it looks fine to me. Like I'm sure it runs faster when you're not screen sharing like this. But
yeah, absolutely. I want to get back to the attract. So you've got this scrolling marquee. So this is obviously being updated and re-rendered every single frame as this animation is going forward and so on. You've got the pulsing colors as these things cycle through. So all of this screen is being re-rendered on every frame. And great performance. I mean, if we want to see some real performance here, here's another of the demos that I put together for the showcase.
Oh, wow.
That's crept off the screen. Let me drag it back in. So this basically is showing a whole bunch of active tiles. And this is exploiting all of the capabilities of SkiaSharp 4.
Look at that.
So
that's serious math going on in each tile.
On each tile, absolutely. You've got Mandelbrot resolutions, you've got plasma in the background. Each of these tiles is being updated. It's responding to the mouse over events and so on.
Yeah,
and all of this
amazing.
kind of tuned. I've got all these different effects. So if I get rid of dissolve and iris, then as I click on something, you can see it animate into the foreground and bring it in as the mouse moves over it. But if I go into here, I can actually turn on microphone input. And so now as I speak, you should see there is a analysis tool here. So that's live fast Fourier analysis of the microphone input updating that tile. It also impacts, you can see the background plasma is pulsing. So, this is my voice live being processed as I speak, updating the rendering whilst it's still doing everything else. And this is the Uno platform. This is C#. This is SkiaSharp 4. All of these effects are being delegated to your GPU. It's all being accelerated and so on. But there's still all this processing capability to run all these other tiles, all these other animations, all these different things going on at the same time. So again, we had a lot of interest with this particular demo as well, really highlighting that it's not just for business, right?
Yeah. This is so much fun. And let me see if I can find that again. So this is the SkiaSharp repo. So if you folks want to just tinker around, there's a fiddle right in there. That's also a WASM app. So it runs on your browser. You can see the math, and you can have different types of effects and shaders. Just trying to play around, like right there. Let's try the Skia fiddle. So you can see the math, and you don't need to do all of the math by hand, because that's what the agents are good at. So just tinker and see. Everything is in the browser. You can change up the animations and things like that. But there's a lot of math going on behind the scenes that you're not seeing, because the performance is just so good. All right. Yeah, this is amazing stuff. Daren, I'm just looking at the time. We have blown past an hour, and we can keep going, I'm sure. But
Yes,
you got work to get back to, so do I. But this is amazing, and such an awesome showcase of using the foundational powers of Luna platform and SkiaSharp, but then layering it with AI, and you have a full-on engine at this point as to how you generate these games. Like, you have everything documented to the T, where no matter what agent you're using, they're going to fall into that bit of success. They know exactly how to build stuff.
Right.
Yeah, so this is amazing. So let me ask you a different question. So while all of this is super fun, how much of this translates over to your workflows at Kahua, like what you folks are building for enterprise?
So, the template of what we're doing is 100% what I do day in, day out when I'm working on Kahua. The prompting, making sure that my prompt is expansive enough to capture exactly what it is that I want. I always have this mindset of imagining that the AI agent is an incredibly intelligent college graduate that has zero experience with my application framework, zero experience solving problems in the real world. How would I mentor that graduate so they were successful? Would I give them a one-word, one-sentence instruction, or would I sit down with them and turn around and say, look, this is what we're trying to do. This is the area of the code base I want you to look at. This is the existing patterns that I wish you to subscribe to. This is what the definition of success is. If you have any questions, don't make stuff up. Ask me. Right? Let me know where you're going. Write down what you've done, and let's review before you move to the next step. Right? That's how you would mentor
exactly.
stuff. And so I treat AI in the same way: is assume nothing, be explicit about what I want, make sure that there are natural checkpoints in there so that I can easily verify that it's on track, and verify at the end, with testing, with getting hands-on with the implemented feature. Just don't imagine that it's going to get everything right. That's a quick path to disappointment, right?
Yeah.
But over time, it's going to improve. And how does it improve? You create memories, you create architectural documents that it can use as references when it's building the next thing in that pattern. And so everything evolves. And we ourselves, we improve with how we write prompts and so on.
Yeah. Very, very wise words. You're really, channeling all of this power to make it work your way. Yeah. So, all right, Daren, this is very enlightening. Thank you. Thank you for showing me all of this. If nothing else, I want to take down your desktop here for a second. But the showcase that you built was just amazing. I hope we get to show it in more and more places, because it's it's eye candy, but at the same time it shows the process and how to employ this for your enterprise workloads. So, Daren, we thank you for all that you do. You've been doing this for 25 plus years, and Yeah, there you go. Hawkman is loving it. So, and you're starting to put this out, so people can actually play with this. Yeah, thanks, Daren, from Sasha as well. So you'll have all of the source code. You'll see how Daren, makes the AI agents work and fall into a bit of success. So yeah, Hawkman and Alvin and Sasha and everybody else watching live, thank you so much for your time, and we appreciate you hanging out with us. We'll put this up on the YouTube soon enough. Wait, is the echo coming from me or maybe not? Maybe a little bit from your side, but
Just
that's
lost
all right.
your audio sound.
Yeah,
Your audio's back now.
yeah, I might be losing my microphone here a little bit. Let me mute my. All right, and I'm back. Hopefully, it's taken care of. Yeah, somewhat, maybe a network glitch. But thank you so much, Daren, for taking an hour out of your busy day. I know you're just getting started with work stuff, so I appreciate your time very much, and I hope to see you in person somewhere soon. And chat room, thanks. Yeah, thanks for hanging out with us. This has been an episode of Pragmatic Show. We'll be back in 2 weeks, another Thursday, where we'll talk to somebody else to talk through more real world AI. All right, folks, that's it from us, and that's the stream. Thank you so much. Take care, be productive, and we'll see you on the next one. All right, bye now.